Hi class, my name is Ryan Carney, and I'm going to be going over extended classes and interfaces as well. So in order to do this, I first started out with the shape class, and this is actually going to be an abstract class. So an abstract class can have normal methods and fields as well, but it can also have abstract methods. And these abstract methods are just going to be a declaration of the sorry, my battery is running low. But these methods are just going to be a declaration of the actual method. So as you can see here, for this abstract int get number of sides or get num of sides, all it has is the header and then the semicolon to tell that the statement is done. So that's just what an abstract method is going to be. But as you can see, it also has normal methods like the toString method. So this shape class is going to be the super class for two other classes that I made, one square and one cube. So in order to become a subclass or to have shape as your superclass, just for example, on this square, we're going to have the extends and then shape. And as long as these guys are in the same package, there's no problem. And you just have the square, extends, shape. And that's going to make it so a square is a subclass of the class shape. And this is a very special relationship because this shape is almost like an outline for what a square has to be. So we see that the abstract int get number of sides and abstract color get color are two required methods. And as you can see in here, we have our get num of sides and get color. So this is pretty much also just saying that a square has to have a number of sides and a color. I also added in a side length, but that's going to be for something later. And next up, we have the cube class, which also extends shape. This one also has a number of sides, six. I guess you could say faces, but I just use sides a little easier. And then also has a color. And then you can see here, it also has the get num of sides and get color. And that is going to be what is required because it's an extension of the class shape. And that means that cube is a subclass of the class shape. Now we can see this super keyword here, and this is actually going to be really useful when dealing with subclasses and superclasses because the super keyword pretty much just invokes the method of the superclass. So as we can see right here, we just have super and then almost like what a constructor would be. So if we just have, we can almost act as if this says shape and then our no argument constructor for shape. So when we construct a cube and also when we construct a square, then the shape constructor is going to be called. So it's going to be new shape created is going to be printed out anytime we print out or anytime we make a new square or a new cube. And when you're making these abstract methods that have to be required for the subclasses, it's just literally abstract and then whatever you'd write. So it'd be abstract and then int is the return type and then get num of sides is the name. And now both these methods have it. So we also have interfaces when doing these. And as you guys can see here, we have three-dimensional and two-dimensional, which are the two interfaces. So the interfaces are very similar to abstract classes, but the thing is that interfaces can only have abstract methods, and you don't actually need to use the keyword abstract because it's just implied with it being an interface. So we can see here for three-dimensional, int get volume is the only method that a three-dimensional shape or whatever has to have. So as you can see in our cube, which implements three-dimensional, I forgot to mention, if you want to have an interface that's implemented, you just put the keyword implements and then the name of the interface, and then it has to implement or it has to have a get volume method. And for a cube, it's very easy. It's just the side length times three. So that's why in our constructor, we have our a side length just right here, just so we know, how big the shape is. And then same thing for two-dimensional. The only method in here is just get area. And this is just an abstract method, as you would say, but you don't need the abstract keyword. and it's literally just the declaration. So it's just int get area, and then it has whatever parameters you might want to have, and then the semicolon. And as you can see in the square method, the get area method is implemented here. And when you're writing an interface, it's just the same thing as a class almost, but it's public, interface, and then the name. Now, in order to kind of show all these methods and interfaces and stuff like that, and polymorphism as well, I just wrote up some statements. So I created one square with the name shape1 and one cube with the name of shape2. And then I'm just having it print out the number of sides. So it should be four for a square and then 6 for a cube. And then our colors. So it should be printing out the blue for our first shape and then the cyan for our second shape. And then we can see our get area. And I just added a little unit squared just to differentiate between the two. And then, I might actually add a space right here. And then we have our shape1 toString. Now, this is a case where dynamic binding allows us to use polymorphism, which is very useful in coding because as you can see, I have two toString methods. ToString is a very common method that you're going to see implemented a lot. So when we have our toString method, we want to be able to use it in different ways. So for mine, I had a square have its toString method as hello, I'm a square with a side length of and then blank. And then for a cube, I had said hello, I'm a cube with a side length of blank. And dynamic binding allows us to have call the same method, but have it do different things, which allows for polymorphism. So we can do multiple things, but have the same method name. So every toString method is doing the same type of thing, but it might just have a couple of different details. So if we run it right here, we can see that we have two new shapes created, which is perfectly. That's using our super keyword. And then get number of sides. It should be, yes, 4 and 6, because a square is 4 sides, and then a cube has 6 sides. And then we have our color, which one is blue, one is cyan. And then we have our get area, which is implemented in our square class. And that is perfect because if our side length is 3, 3 squared is 9. And then for our cube, with a side length of 4, 64 cube or 4 cubed is 64. And then as we can see here, the dynamic binding allows us to use or enables polymorphism. And so we can have the same method call, but have two different outputs, which is a very powerful thing in Java. I hope you guys got a little better understanding of extended classes and interfaces. That's all I got for you. Have a good one.